Hello everyone. In this video, we're going to learn how to solve the quadratic equation by taking square root and completing square. Alright, now we have two formulas right here. This is complete square. If a square plus 2ab plus b square is going to be equal to a plus b altogether square. If a square minus 2ab plus b square is going to be equal to a minus b altogether square. And you have the formula if s squared equals a. When you take square root both sides, it turns out to be s equals plus and minus square root of a, right? Where a greater than or equal to 0. This guy actually turns out to be square root of s squared equals square root of a. And then square root of s squared, it turns out to be absolute value of s equals square root of a. Now absolute value of s equals square root of a. It turns out to be s equals square root of a. And s equals negative square root of a. That's why we have the formula right here. Alright, now let's take a look at the first example. S squared minus 4 equal to 0. Right, now I need to add 4 both sides. So it turns out to be s squared equals 4. Now I need to take square root both sides. So square root of s squared is turns out to be s. Square root of 4 turns out to be 2. And don't forget plus and minus 2. Alright, so keep that in mind. So we have two solutions, 2 and negative 2. Now let's take a look at the second example. S squared plus 4 equal to 0. Alright, so subtract 4 both sides. It's going to be s squared equal to negative 4. This equation has no solution because on the left hand side s squared always greater than or equal to 0. The right hand side is negative 4 less than 0. So this guy cannot be equal to this guy. That's why we have no solution. Alright, now let's take a look at the next example. S squared minus 15 equals 0. Alright, so you're going to add 15 both sides. It turns out to be s squared equals 15. Right, now you take square root both sides. It turns out to be s equals plus and minus square root of 15. Alright, so we have two solutions. Now let's take a look at the next example. S squared minus 32 equals 0. Right, now I need to add 32 both sides. It's going to be s squared equals 32. Right, and then I'm going to take square root both sides. It's going to be s equals plus and minus square root of 32. Alright, so you need to simplify. Right, square root of 32 can be written as plus and minus square root of 16 times square root of 2. Right, because 32 can be written as a perfect square 16 and a prime number 2. So when you take square root of 16, it turns out to be 4. Right, so this guy turns out to be plus and minus 4 root 2. Alright, keep that in mind. You always simplify your answer. Right, now let's take a look at the next example. For example, s squared equals 0. And then when you take square root both sides, it turns out to be s equals plus and minus square root of 0. Right, so this guy actually 0. So the answer is s equal to 0, right? So keep that in mind. You have one solution. Now let's take a look at the next example. 2s squared minus 18 equals 0. Alright, so I need to add 18 both sides. It turns out to be 2s squared equals 18, right? And then divide both sides by 2. So s squared equals 9, right? And then you take square root both sides. It's going to be s equals plus and minus square root of 9. It turns out to be plus and minus 3, right? So the solution is 3 and negative 3. Now let's take a look at the next example. 2s squared minus 15 equals 0. Now you need to add 15 both sides, so it's going to be 2s squared equals 15, and then you divide both sides by 2, so s squared equals 15 divided by 2. Alright, and then you take square root both sides. It turns out to be s equals plus and minus square root of 15 over 2. Now this guy can be written as plus and minus root 15 over root 2, right? You need to radicalize the denominator by multiplying the numerator and denominator by denominator, right? So I'm going to multiply the numerator and denominator by root 2, right? So the numerator turns out to be plus and minus root 30, right? Denominator turns out to be 2, right? Because root 2 times root 2 equals 2. And this is the final answer. You cannot simplify this one further, right? Now, if the quadratic equation doesn't have complete square, you need to make it complete square before you apply this method. Alright, so let's take a look at this example. S squared plus 12s minus 13 equals 0. Alright, so in order to apply this method, you need to move a constant to the right hand side, right? So I need to add 13 right here, both sides. So it turns out to be s squared plus 12s equals 13, right? Now, in order to make this one complete square, I need 3 terms. Now you look at this one. The one with s right here is the middle term. So look at this one. This is the plus sign. So we're going to apply the first formula right here because the middle term has the plus sign, right? Now I have 2 terms, the first term and the second term right here. Now I need the third term right here. So how do I find the third term? I need to take the middle terms, which is 12, and then I divide by 2, and then I square, and that is the third term. Now I need to simplify this guy. 12 divided by 2, it can be 6, right? So I put 6 square right here, right? So I add 6 square. Now you just literally add 6 square on the left hand side. You need to do the same thing on the right hand side. So the equation doesn't change, right? Now we just end up with 3 terms right here. So it turns out to be a plus b altogether square, right? This is a square plus 2ab plus b square. So this guy turns out to be s plus 6, right? A equal s, b equals 6. So s plus 6 altogether square equals. Now 13 plus 6 square equals 36. So it turns out to be 49. Then this is a complete square, right? Now I need to apply this formula right here. So it turns out to be square root of s plus 6 altogether square equals square root of 49, right? So this guy turns out to be s plus 6. And then this guy turns out to be plus and minus Square root of 49 equals 7. So from here, I can rewrite this one as s plus 6 equals plus 7, right? So 7 right here. And the second one, s plus 6 equals negative 7, right? Now I need to solve this one. So it turns out to be s equals 7 minus 6, it could be 1. And this guy, s equals negative 7 minus 6, it could be negative 13, right? And we have two solutions, 1 and negative 13, right? Now let's move on to the next example. For example, we need to solve s squared minus 14s plus 16 equals 0, right? Now, in order to apply this formula right here, we need to move the constant to the right hand side, right? So s squared minus 14s equals negative 16, right? Now, we need to take the middle terms right here, divide by 2 and square. Keep in mind, the middle terms right here, don't worry about the side right here. You just take 14, you divide by 2, and then you square it. So it's going to be 14 divided by 2, it could be 7. 7 squared, it's going to be 49, right? So I just write 7 squared, right? So I add 7 square right here. Now I just add 7 square to the left hand side. I need to do the same thing on the right hand side, right? So this guy right here, I need to apply the second formula. It turns out to be a minus b altogether square, because I have the subtraction sign in the middle terms right here, right? The subtraction sign right here. Alright, so it turns out to be s minus 7 altogether square equals negative 16 plus 7 square equals 49, right? So it turns out to be 33, right? Now, I need to take square root both sides using the formula right here. So it's going to be s minus 7 equals plus and minus square root of 33, right? Now, I need to split this one into different cases, right? S minus 7 equals square root of 33, and s minus 7 equals negative root 33. Now I need to simplify. And keep in mind, 33 is a prime number, so you cannot take square root of this number. So you just leave it, right? So I just add 7 both sides. So it turns out to be s equals square root of 33 plus 7, and s equals negative square root of 33 minus 7. And we have two solutions, right? Now let's take a look at the next example. For example, we need to solve 4s squared plus 12s minus 44 equals 0. Alright, so I look at this one, I see that the GCF of these three terms is going to be 4, right? So if you can divide both sides by the GCF, go ahead do that first before you solve the quadratic equation, right? So I'm going to divide both sides by 4. So this guy turns out to be s squared plus 3s minus 11 equals 0. Alright, now I need to add 11 both sides. So s squared plus 3s equals 11, right? Now I need to find the third terms right here by taking the middle terms, which is 3 divided by 2 and square, right? So I have plus 3 divided by 2 altogether square, right? I just literally add 3½ square on the left hand side. I need to do the same thing on the right hand side. So 3½ square, right? And then the left hand side, I need to apply the first formula right here. This is complete square, right? So it turns out to be s plus 3½ right here altogether square. Now the right hand side, I need to simplify this one. So 11 plus 3.5 square, right? So 3.5 square, which means 9 over 4. And then I'm going to add 11. So I just multiply this guy by 4, right? So it turns out to be 9 plus 44 over 4, right? So it could be 53 over 4, right? So I put 53 over 4 right here, right? Now I need to take square root both sides. So it turns out to be s plus 3.5 equals plus and minus square root of 53 over 4. So this guy can be written as plus and minus square root of 53 over square root of 4. And we need to simplify. It turns out to be plus and minus square root of 53 over 2, right? So we have two different cases. The first one as plus 3.5, right? Right here equals square root of 53 over 2. And the second one as plus 3.5 equals negative square root of 53 over 2. Alright, so in order to solve the first one, I need to subtract 3.5 both sides, right? So this guy turns out to be s equals square root of 53 subtract 3 over 2 because they have the common denominator, right? Now the bottom one you need to subtract 3.5 both sides, so it turns out to be s equals negative root 53 minus 3 over 2. So we have two solutions. Alright, so let's move on to the last example, the work problem. You are planning a flower garden consisting of 3 square plots surrounded by a 1-foot border. The total area of the garden and the border is 100 square feet, right here. What is the side length asked of each square plot? Alright, so the first plot we have the side length right here, S and S. The second one is still S and S right here, right? And the third one S and S right here, right? Now the border has the width of 1 foot, right? Alright. So the total area of the garden and the border is 100 square feet, right? Now, because this guy is the rectangle, so the area of the rectangle equals length times width, right? So the length is going to be from here to here. And the width is going to be from here to here. Alright, so I need to find the side length, right? From here to here, it's going to be S, right? From here to here, it's going to be another S. From here to here, it's going to be another S. So total, I have the length is going to be 3S. Now, don't forget the border right here. From here to here, it's going to be 1 foot. It's going to be right here. And from here to here, it's going to be another 1 foot, right? So total is going to be 2. So I need to add 2 right here. Alright. Multiply by the width. I have the width from here to here is going to be S, right? And then the width of the border right here is going to be 1, right? The width of the border right here is going to be 1, right? So total I have 2. I need to add 2, right? And then this guy equals 100. Alright, now I need to distribute this one using box method. Alright, so I put 3s right here, I put 2 right here, right? 3s plus 2. Now s plus 2, I put s right here and 2 right here. Now I need to multiply this guy out. So 3s times s, it could be 3s squared. S times 2 is going to be 2s. 3s times 2 is going to be 6s. And 2 times 2 is going to be 4. Alright, so this guy turns out to be 3s squared. And 6s plus 2s is going to be 8s. And then 4 right here, rewrite 4 equals 100. In order to make this one complete square, I need to make the coefficient in front of s squared 1. So I need to divide both sides by 3 first. So keep that in mind. Divide this guy by 3, it turns out to be s squared. Divide this guy by 3, it turns out to be 8 over 3s. And divide this guy by 3, it turns out to be 32, right? Now, to make this one complete square, I need to fill in the blank right here, right? So basically, the middle terms right here, 8 over 3. I need to divide this guy by 2 and square, right? So 8 over 3 divided by 2. It turns out to be 8 over 6, right? And then I square this guy. Right, so now I need to simplify this guy. It turns out to be 4 over 3 altogether square, right? So I need to add 4 over 3 altogether square. And this guy, I need to add 4 over 3 altogether square, right? And then we have 3 terms right here. We need to apply the first formula right here. So it turns out to be a plus b altogether square. A is s, b is 4 over 3. So it's going to be s plus 4 over 3 altogether square equals. Now you need to simplify this guy, right? So 32 plus 4 square equals 16. 3 square equals 9, right? So I need to multiply this one by 32 and then write the whole thing in the same denominator 9, right? So it turns out to be 304 over 9, right? So I need to write this one as 304 over 9. Alright, so we have s plus 4 over 3 equals square root of 304 over 9. And s plus 4 over 3 equals negative square root of 304 over 9. Right, so now we need to simplify by subtracting 4 over 3 both sides. So it turns out to be s equals square root of 304 over 9 minus 4 over 3. And s equals negative square root of 304 over 9 minus 4 over 3. Now we look at this one right here because s is the silent, so s must be greater than 0, right? So this guy is less than 0, so this guy not a solution, right? Now we only have one solution right here. S equals square root of 304 over 9 minus 4 over 3. And if you hit the calculator, the answer must be approximately 4.48 feet. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.